So good day everyone. Our topic is all about the BCD and ASCII conversion. So BCD stands for the binary coded decimal number system. So it is needed because in everyday life we may use the digits from 0 to 9 for numbers. So binary representation such as 0 to 9 is called the BCD. So in our computer literature there are two terms for BCD. We have unpack and BCD pack. So from digit 0 to 9, we have this equivalent binary code representation. Okay, so we have first the category, the unpacked BCD. So the unpacked BCD, the lower 4 bits of the number represents the BCD numbers, and the rest of the bits are 0. For example, so 0, 0, 0, 0, 1, 0, 0, 1. So these 4 bits represents the BCD number, which is in fact for the BCD number 9. So actually the unpacked BCD requires 1 byte of memory, meaning an 8-bit register. So have 1 nibble equals to 4-bit, or 8-bit rather, so to contain it. On the other hand, we have packed BCD. So in packed BCD, we have a single byte, 8 bits also, has 2 BCD numbers in it. One in the lower 4 bits and one in the upper 4 bits. So for example, we have 0101 and 1001. This number is a packed BCD for 59 hex. So we have 5 for this one and 9 for this one. So 1 byte of memory is needed to store the packed BCD operands. Thus, one reason to use packed BCD it is because it is twice as efficient in storing data. So liman ka kung compare ng sa unpack, ang upper na nibble di mo magamit kaya puro siya 0. Ang lower ang magamit. But on the other hand, the packed BCD ang duha ka nibbles ang imuhang magamit. So we have the upper nibble and the lower nibble. So for ASCII numbers, when the key 0 is activated, actually we have 011, 000. So it is to provide to the computer mo na tong binary representation for the ASCII for the 0 kung i-press na to ang keyboard. So here is the equivalent of the ASCII for the keys that we have in our keyboard. For example, we have 0, 1, 2, 3 up to 9 in our keyboard. The equivalent ASCII code is this one. As you can see, it all starts with 3. And the binary representation also starts with 3. And as you can see, the unpacked equivalent of that number is as is ang mga lower nibble, as is na siya. But as you can see for the upper nibble, 0 tanan siya. Okay? So that is for the BCD unpacked. So it must be noted that BCD numbers are universal. Although ASCII is a standard in the United States and many other countries, because the keyboards, printers, and monitors all use ASCII, data must be converted from ASCII to BCD and vice versa. So that is why it is very crucial to know how to convert the BCD to ASCII and ASCII to BCD because most of our peripherals use it. Okay. For the packed BCD to ASCII conversion, so actually in many systems we have what is called real-time clock. So the real-time clock provides the time of the day, the hour, the minute, and the second. And we also have the year, month, and day continuously, regardless of whether ang atong system is on or off. So this data, however, is provided in fact BCD. So for this data to be displayed on device such as LCD or to be printed by our printer, it must be converted in a ASCII format. So to convert BCD to ASCII, we must first convert it to unpack. So first, para ma-convert nato ang BCD to ASCII, first kinahanglan nato siya i-unpack BCD. So then the unpacked BCD is tagged with 01100 or 30 hex. So mao na ang iyahang default kumbaga. So good. We have 011. Okay. So for example, we have 29 hex. So if we convert it into a binary representation, we have 2 as 0010 and 9 as 1001. Okay? So now we need to unpack the BCD. First is for the 2 hex. So this 2 hex, again, let us recall, when we unpack the BCD, we need to have the 0 for the upper nibble. So the lower nibble as is, so we'll have the value of 2 hex as 0010, and then have the value of the upper nibble on it as 00. So we have all in all for 02 hex, we have 0000 0010. That is for 2 hex. How about for 9 hex? So the same steps, the same procedure. So for 9, we have 1001, and then that is for the lower bits, a lower nibble rather. For the upper nibble as is, all the nibble has a value of 0. Okay. And then we already have unpacked the BCD. So after unpacking the BCD, now we need to convert it to ASCII. To convert it, we need to tag it with 30 hex or 011 for the upper nibble. So copy the lower nibble, we have 00110, and then tag 0011 for the upper nibble. So for the 2 hex for the unpack, we have an equivalent ASCII as 32 hex. So we have 0011 0010. Same procedure that we will do for 9 hex, we have lower nibble as is, upper nibble tagged with 30 hex. So we have 0011 1001. Okay? For the conversion of 9 hex to 39 hex to be an ASCII code. Okay. So we have here an example. So assume that the register 20 has a packed BCD. So upper nibble and lower nibble. So the task is to write a program to convert the packed BCD to 2 ASCII numbers and place them in register 21 and register 22. So basically, we need to separate the two. Number, we have the lower nibble and the upper nibble. So in this example, we have the BCD 29 hex, the packed BCD 29 hex. We need to separate the 2 and 9 to register 21 and register 22. So register 21 for the lower byte or the 9, and the upper nibble register 22. So to do that, first we need to store the 29 hex, the BCD, to register 21. So, and after that, we have register 21. So, a register 21 is, okay. So, our register 21 now has a value of 00101001. Okay? That is equivalent for 29 hex. And then the next step is to add immediate. Okay, sorry. So we need to mask the upper nibble, meaning we need to zero this out. So, para mahimo siyang unpack. So in order to do that, we need to mask it with a value of 0f hex. So the equivalent of 0f hex, we have 00001111. Okay? And these two operands, we have, and them together, 111, 001, 0000. Okay? So that is our value of register 21 after masking it. Okay? So now, we need to convert it to be an ASCII. So in order to do that, as I've mentioned before, we need to tag 30 hex of that number. So 30 hex is, what is the value? 0, okay, 0011. Okay, so we have 011, kini and kini di or nato. 0011, 000. All them together we have 1001, 1100. So this is our value of the ASCII. We have 3, this is 9. So we have 39 hex as the value of the register 21 or the lower nibble. So, and for the upper nibble, we have 2. These 2 here. So, how can I erase this? Okay. So, same step as we did earlier, we need to move the 29 hex, our default value, to register 22 to get the value of our upper. So, our value of register 22 now is equivalent to 29 hex. But we are not concerned with the lower nibble, but we are concerned with the upper nibble. So, since we are concerned with the upper, we need to swap them together. So, after swapping, so, ang atong upper na nahimong 9, ang lower naging 92. So, register 22 now is equal to 92 hex for this step. And then we have 92 hex. So, now, this 92 hex, we need to mask the upper nibble. Para mahimo ng 0, we need to mask it. Mask. So, the value of register 22, actually, we have 1001, 0010. To mask it, we have 0fx. So, we have 0001111. Okay? So, under them together, we have 01, 0, 0, 0, 0, 0, 0. So, we have the unpacked value. Unpacked BCD. So, we have 0, 0, 0, 0, 0, 0, 1, 0, or equivalent to 0, 2. So, in order for it, this is an unpacked BCD, right? Before we have the ASCII equivalent, we need to again tag the 30 hex in the upper nibble. So in order to do that, we need to OR it. So we have, okay, di na ako isa ma-go. Okay, nawala ko. Okay, na-erase akong dislike. Okay. So we have 9, balik na ako ha. So we have 1001 0010. This is equivalent to 92 hex. So, and after that, we need to mass it. So what we have left is 02. And then, this is an intact BCD. To convert it to ASCII, we need to have ORing it. So we have 0000010, ORing it with 30 hex. 0011 0000 0100 1100. So we have 32 hex as equivalent for the ASCII. Okay? Okay. So that is from BCD to an ASCII. How about ASCII to BCD? So, pabali na po ta. So, from ASCII to FAT BCD, you need to first convert to unpack BCD to get rid of the 3 and then combine it to FAT BCD. So, ganun na, from BCD, i-mass natin siya, then himuon natin siyang unpack, and then unpack, then OR to have the ASCII. And for ASCII to FAT BCD, we need to convert it to unpack and then combine it to the BCD. So for example, we have 4 and 7. So the keyboard gives 34 hex and 37 hex respectively. Okay. So to convert it to BCD, first we need to unpack, then combine it together. So we have 4 equivalent is 34, 7 equivalent to 37 hex. Or we have this value for the unpack. So in order for it to be unpacked, we need to have the upper nibble as 4. So just recall it. And then for the back BCD, we just need to combine the upper or the most significant bit with the less significant bit. So this 4 now is here, and this 7 is on the lower nibble. So for example, we have 4 loaded to register 21 or stored in register 21, and 7 stored in register 22. So first we need to, in order to do this, we need to mask the upper nibble. So we have 0x, 0f or 0f hex. So we have, okay, we have here, first let's get into register 21 is equivalent to 4, okay, and mask the upper. So we have actually, so what we have is 0000 0100, okay. So mask it with the upper nibble. We're showing 0000 0. This is 1 1 1 1. So under them together to have 0. Oops. Next one siya. So 000 0100. So, parang upper nibble ma-mask or ma-zero. Okay, so, okay, this is wala naman 0, 0, 1, 0, 0 lang. Okay, and then, swap the register 21. So, iswap nato ni, kaya register 21 mo naman ni no. Swap them together, so we have the upper nibble now is 0, 1, 0, 0, 1, 0, 0, and the lower nibble is 0, 0, 0. Okay? So, mana na ang upper nibble sa BCD. This is R21. So, this is the output after this instruction. For the register 22, same method that we have done for the register 21. So, mask the upper nibble of register 22. So, after masking it, we have register 22 equivalent to 0, 0, 0, 0, 0, 1, 1, and 1. Oh. Oops. Nawala na. Okay. 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 So, register 22 is equivalent to, after masking it and using this instruction, we have 0, 0, 0, 0, 0, 1, 1, 1. Okay? And then, na siya. Dili na nato necessary i-swap na siya kay since ang 0, 1, 1, 1 which is equivalent to 7 is the lower nibble. So, we don't need to swap. So, in order for it to be a BCD, we need to combine it together by using an instruction OR. So, recall that our register 21 is after swapping it, we have 0, 1, 0, 0, 0, 0, 0. After natin na-swap. So, all in it, we have kining R22 i-OR nato sa register 21. So, we have 0, isulat na ang balik, 0, 0, 0, 0, 1, 1. That is register 22. And for the register 21, we have 0, 1, 0, 0, 0, 0, 0, 0. All them together, so we have 0, 1, 1, 0, 0, 1, 0. So this is equivalent to 0, 1, 0, 0, 0, 1, 1, 1, which is just equivalent to this. So we just have converted the ASCII to BCD. And then, in order for it to be stored in one register, we just need to transfer the value of register 22 to register 20. Okay, that is all for the topic for the BCD numbers, ASCII to BCD and BCD to ASCII. So, thank you.